Hi everyone. Today I'm going to complete this paper. This is the second video of this paper. Uh, Paper 41 means paper 4, variant 1, mechanics, October, November 2019. So let's start. Okay. Question number 6. The first question I have discussed in the first video. This is the second video, so I'll start from question number 6. A particle of mass 0.4 kg is released from rest at a height of 1.8 meter above the surface of the water in a tank. So you should analyze your data while reading your question and write for this will help you a lot in the solution of the question. So you can see from rest, it means initial speed of that particle is 0, that is u. The mass of the particle is also given 0.4 kg, and the height means the particle will cover the distance. So this will be the distance, 1.8 meters. So height can be called as a distance as well. There is no instantaneous change in the speed when the particle enters the water. The water exerts an upward force of 5.6 newtons on the particle when it is in the water. Find the velocity of the water particle at the instant when it reaches the surface. So there is one more thing which we know. For falling bodies, we know that there is a gravitational acceleration g, which is 9.8 exactly, but we'll use 10 for our convenience in maths. So we need to find v, the final velocity before the particle hits the water. Okay, so if you scan the data carefully, we can use the third equation of motion, which is 2gs is equal to v square minus u square. So just put the values. 2 into 10 into 1.8 is equal to v square minus 0 square. So this will be like 36 is equal to v square, or v is equal to 6 meters per second. We'll ignore the negative 6 because the particle is accelerating, so velocity should be increased, so there will be no negative 6. So this is the answer of part 1. Now the second part is find the time that it takes from the instant when the particle enters the water until it comes to instantaneous rest in the water. Means when the particle will reach either on the bottom, at the bottom of the tank. You may assume that the tank is deep enough so that the particle does not reach the bottom of. Okay, it means the particle will actually comes to instantaneous rest before the bottom, above the bottom. Okay, now for this we need one thing, which is upward force of water, that is 5.6 newtons, which is given in the question. So we'll use this in this part. Also the weight w, weight of particle, which is w is equal to mg, that is 10 into 0.4, which is 4 newtons. Okay, now First of all, we'll find the acceleration of the particle in the water. So we'll not use g because the particle is not falling freely now, it is in the water. So we have to find the acceleration. So for this, actually we'll use the by second law of Newton. F is equal to ma. Here F will be the resultant force. What is the resultant force? Weight minus upward force of water, because water is exerting upward force and the weight is actually acting downward. So the resultant will be weight minus upward force. Mass of the particle is 0.4 into A we are going to find. So put the values. Weight is 4 minus upward force is 5.6 newtons is equal to 0.4 A. So this will become minus 1.6 is equal to 0.4 A. Bring this 0.4 on the left side. Minus 1.6 over 0.4 is equal to A, or A is equal to minus 4 meters per second square. This negative sign is showing that the particle is actually decelerating because of the resistance from the water. The water is decelerating. Now I need to find the time. Look at the question. Find the time that it will take to become instantaneously at rest. So I need to find time. So for time, I got u is equal to 6 meters per second, because in the first part the final velocity becomes the initial velocity when the particle enters the water. So that's why this is from the first part where the final velocity was v. Now it becomes u because now the particle enters the water. So this is our initial velocity. Final is 0 because we know that the particle will come to instantaneous rest. So final 0. We got A, which is minus 4 meters per second square, and we need to find T. So if you look closely, we can use the first equation of motion, which is by first equation of motion. V is equal to u plus at. So V is 0, u is 6 minus a means minus 4 into t. So take t on the left side, it will become 4t is equal to 6, or t is equal to 6 over 4, t is equal to 1.5 seconds. This is our answer. Okay, the part 3. Sketch the velocity time graph for the motion of the particle from the instant at which it is released until it comes to instantaneous rest in the water. So we need to plot the graph of two scenarios. First, when the particle was in air, then when the particle was in water. So the complete journey of particle will be drawn here. So this is the velocity time graph. So the velocity is always along the y-axis and time is always along the x-axis. Okay, this is 6 because particle got velocity at the end of its first journey 6, and if you find out the time was actually at that moment was 0.6 second. So the first part of the journey will be this one. Particle was accelerating continuously. So the straight line is showing the particle is accelerating constantly because that was g. So g is always constant. At this moment, the particle hits the water, and right at this moment, the particle will start deceleration. So the line will move downwards. So for this, the particle took 1.5 seconds from the surface of the water to comes to instantaneous rest. So rest means the particle will the particle will touch the x-axis, the graph will touch the x-axis. So this will be like this one. This is the negative -4 constant deceleration, and this time is 1.5 seconds. So the total 1.5, 0.6 plus 1.5 is 2.1 seconds. So at 2.1 seconds, the particle will come to an instantaneous rest. So this will be the velocity time graph for the particle. Okay. Now question 7 is, a particle moves in a straight line starting from the rest at O and comes to an instantaneous rest at P, at a point P. So there are 2 points where the particle was at rest. One is O and one is P. The velocity of the particle at time t seconds after leaving O is v meters per second. Okay, where this is our main equation of the velocity. Show that the distance OP is 6.25. Okay. Now, first of all, this is our equation. V is equal to 0.6 t square minus 0.12 t cube. Okay. So at instantaneous rest, the velocity should be 0. Okay, we'll find the time when the body will be at instantaneous rest. So this will be 0.6 t square minus 0.12 t cube is equal to 0 because v is 0. So we'll solve this. Take 0.6 t common. So this will become t minus 0.2 t. So either 0.6 t or 0, or this is 0. So 0.6 t is equal to 0, or t minus 0.2 t is equal to 0. 1 minus. So this is 1. I am taking t square common because this is t cube. So this is 1. So this will give me t is equal to 0. This will give me t is equal to 1 over 0.2, which is t is equal to 5 seconds. This is t is equal to 0 seconds. So these are the 2 times when the body was at rest, as I mentioned earlier. T0 means point O when the body started, and T5 second means at point P, because at point P the body was again at rest. So these are the 2 times. Now I'll keep these values for later use. Now I got again, I'll write the equation of velocity, which is v is equal to 0.6 t square minus 0.12 t cube. Okay, I know that the velocity means ds by dt, total distance divided by total time, means velocity. So I can write it as ds by dt 0.6 t square minus 0.12 t cube. So now I am going to find the formula for distance. So take dt on the other side. So ds is equal to 0.6 t square minus 0.12 t cube into dt. Okay. Now take integration of both sides. So ds integration 0.6 t square minus 0.12 t cube dt. Now this will become s, and the integration of 0.6 t is 0.6 t square. I got square, so it will become t cube over 3 minus 0.12. I got t cube, so it will become t4 over 4 plus c, the constant of t cube. So s will be, this will become 0.2, this will become 0.03. So s is equal to 0.2 t cube minus 0.03 t4 plus c. Okay, now we need to find the value of c first. We know at t is equal to 0, s was 0 again, because the body did not cover any distance. So t is equal to 0, s is equal to 0. Put these two values here. I'll find the value of t. This to this place. So s is equal to, I'll write the equation again, 0.2 t cube minus 0.03 t4 plus c. So I'll put s equal to 0, t is equal to 0 here. So 0 is equal to 0 minus 0 plus c. So c is 0. So I'll put the value here. So I will get the final equation of distance, 0.2 t cube minus 0.03 t4. This is my final equation of distance body. Now I am going to find the distance OP. It means when the body reaches P, the time was 5 seconds. This was time was 5 seconds. So I will put the time 5 here, so that I can get the distance from O to P. This will be 0.2 into 5 cube minus 0.03 into 5 power 4. So by the calculator, when you solve, you will get the answer as is equal to 6.25 meters. So it is shown that distance OP is 6.25 meters. This is our answer. Okay. Part 2. On another occasion, the particle also moves in the same straight line. On this occasion, the displacement of the particle at time t seconds after leaving O is s. So we are given s. S is equal to kt cube plus ct phi. It is given that the particle passes point P with velocity. This is the velocity at P at time t. find the values of the constants k and c. So first of all, you must know that if we got two constants, it means we should have two equations to solve them simultaneously and get these two constants. So our first priority is to find out those two equations, simultaneous equations. Okay, so we know from the previous part that when t was 5 seconds, the particle was at P and the distance was 6.25 meters. This is from particle from part 1. Now the equation is given, S is equal to kt cube plus ct5. So I'll put the value of S and t here. So this will be 6.25 is equal to k 5 cube plus c 5. Okay, now 6.25 is equal to this is 125. 5 cube is 125k and 5 power 5 is 3125c. So I can write it as 125k plus 3125c is equal to 6.25. This is my first equation. Now for the second, I will use again the equation which I am given with at the start, S is equal to kt cube. Again S is equal to kt cube plus ct5. So, because at P the velocity is given, it means we should find the velocity as well. It means from distance, how we can find velocity? By taking derivative of this distance with respect to t. So ds by dt, take the derivative of this s with respect to t. So this will become, k is constant, so this will become 3 first kt square plus c is constant, so 5 ct4. Now this ds by dt means velocity, so velocity is 3 kt square plus 5 ct4. Now it is given that at P the velocity was 1.25 and time was 5. So at P velocity was 1.25 and time was 5. So I'll put these two things here. So I will get another equation. 1.25 is equal to 3k, I'll put the value of t, 5 square plus 5c54. So this will become 1.25 is equal to, this 5 square is 25, 25 multiplied 3 is 75, 75 k 54 is 6 to 5, multiply 5, which is 3125c. This is my equation number 2. So I got two equations now. I will solve them simultaneously. First is 125, I'll write here 125k plus 3125c is equal to 6.25. The second is 75k plus 3125c is equal to 1.25. So 75k plus 3125 C is equal to 1.25. Now I'm going to subtract them, so sign change. This will be plus and minus. So this will be cancelled. So 125 minus 75, this is 50k. 6 minus 1.25, this is 5. So k got 5 over 50. So k is equal to 0.1. This is the value of first constant. Now you can get the other constant by putting the value of k in either equation 1 or equation 2. So I'm going to put this in equation 1. So 125 from 1. So 125 into 0.1 plus 3125 C is equal to 6.25. So this will become 12.5 plus 3125 is equal to 6.25, or take 12.25 on the other side, 3125 C, this is C as well, is equal to 6.25 minus 12.5. So if you solve with the calculator, it will become C is equal to minus 2 multiplied 10 power minus 3. This is the value of another constant. This is our answer. So part 3 is find the acceleration of the particle at t is equal to 5. Okay, so for acceleration we'll use this velocity equation. So what is velocity equation is? V is equal to 3k t square plus 5c t4. So we know the acceleration means velocity over time. So I'll differentiate with respect to t again, this v. So this will become dv by dt is equal to, so 3k is constant, so it will be 6kt plus 5c is also constant, so it will be 20c t cube. Now I got this t5 here, so put t is equal to 5 here. So now this will become a, acceleration a. Therefore a is equal to, because dv by dt is a, 6 into k. K's value is 0.1. So 0.1 into t's value is 5 plus 20 into c's value is this one, minus 0.002 minus 0.002 into t cube means 5 cube. So after solving it with the calculator, I will get the value of acceleration, which is minus 2 meters per second square. This is the answer. So that's it. This is the end of the question paper 41, October, November 2019. So thanks for watching. Thank you very much.